Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at some examples of solving equations that are quadratic in form. Now, quadratic in form we know means that our higher variable term is the square or double the exponent of our lower variable term. We're going to solve these by making a substitution. So we're going to let y be our lower variable term. In this case, y equals x cubed. Squaring both sides of that, we get that y squared would be x to the sixth. So using that substitution, we get y squared minus 9y plus 8 equals 0. That statement should look much more familiar as a regular quadratic equation that we're used to solving. Now at this point, we've learned many different solving methods, so you can use whatever one you prefer. I always would like to factor if something factors, and this one does. So I'm going to go ahead and factor this to y minus 1 times y minus 8. Separating these and setting them equal to 0, I get y minus 1 equals 0 and y minus 8 equals 0 to give me that y equals 1 and y equals 8. Remember though, whenever we're solving, we are solving for the value of x. So we need to now return to our substitution and remember that y is actually holding the place of x cubed. So I have now x cubed equals 1 and x cubed equals 8. To make that say x equals, I would take the cube root of both sides. Cube root will undo x cubed. And because it is an odd numbered root, a third root, we don't have to deal with plus and minus, meaning we get just x equals positive 1 and just x equals positive, cube root of 8 is 2. So two solutions to this equation that was quadratic in form, x equals 1 and x equals 2. Okay, let's try another one like that. X minus 3 times the square root of x minus 10 equals 0. All right, in this one, it may be a little bit harder to see that this one is quadratic in form. But if we think about the fact that the square root of x squared is in fact x, we can see that we do have that squared relationship here, or that doubling of our exponent. So we can make the same type of substitution. Let y be the square root of x. And that would mean that y squared is x. So now we have y squared minus 3y minus 10 equals 0. Once again, this one will factor, but you can use whatever solving method you prefer. So y and y, things that multiply to give negative 10 but add to give negative 3, I get y minus 5 and y plus 2. Setting those separately equal to 0, y minus 5 equals 0 and y plus 2 equals 0 gives y equals 5 and y equals negative 2. Once again, returning to our original substitution, y is holding the place of square root x. So I have square root of x equals 5 and square root of x equals negative 2. Now, knowing what we know about square roots, our square root of x cannot equal a negative number. The square root is always positive. So this one does not give any valid solutions. Returning to our one remaining, square root of x equals 5, I can square both sides to get x equals 5 squared is 25 as my solution. All right, guys, that does it for this video on examples of solving equations that are quadratic in form. We'll catch you in the next one.